Hello, everyone, and thank you for joining me for this talk. I am Joseph Campbell, and I currently work as a photographer for the National Museum of African American History and Culture here at the Smithsonian. I'm going to be giving a brief talk about the challenges and process of creating a 3D model for the alto saxophone owned and played by the great Charlie Bird Parker. I will not be getting into a lot of detail on this process, but will be highlighting key milestones that had a large impact on future projects. And for a quick comparison, I have the 2D still photograph I captured here on the left for publication, and the final 3D model rotating here on the right. I'm also going to briefly talk about how the Alto Saxophone was a catalyst to extend our digital toolbox, build out 3D related infrastructure, and reimagine our workflows, which you can see some of the various kinds of objects I have had the pleasure to capture for the 3D use cases such as online exhibitions, 3D printing for exhibition use, as well as even accessioning born digital 3D content. So jumping in here, it's good to understand what's easy to capture with 3D tools to give us some perspective on why the alto saxophone was such a challenge. We have a great example of what's easy with this Colono pottery. It has a robust surface with a lot of unique texture. It's opaque. And there's no surface reflections or gloss, meaning it's completely matte. It doesn't have any moving parts. Nothing is really hidden or complicated about shape, and it's an easy object to handle, being that it's about the size of a basketball. The alto saxophone, on the other hand, didn't have any of these easy properties, and is in fact an object we wouldn't normally think was possible to capture for 3D. For example, I've pointed out in this graphic the mirror-like bell, the iridescent pearl keys, the chrome accents, and the overall complexity of the saxophone that all make this an incredibly complicated object to capture with existing 3D tools. In order to control and circumvent the difficult and almost impossible characteristics of the alto saxophone, I created this capture setup that you can see being put together on the right by myself and my colleague Dantes Henderson. This setup was designed completely around mitigating and controlling reflections in the mirror-like parts such as the bell. It provided a very diffuse and even lighting and allowed flexibility in the imaging patterns used for the photogrammetry capture process. And here is a brief glimpse into that capture process, showing me working with the custom setup I made for the saxophone. I used three distinct photogrammetry capture patterns, one with a turntable, a flight path similar to a drone, and then by hand using a macro lens. This is an example detail shot showing how the mirror-like bell is reflecting the white foam boards from that capture setup, which reveals all the intricate details, coloring, and surface information of the mirror-like parts. You can see that this works incredibly well, and it provides a consistent surface for the reflective parts that the photogrammetry software can then use to build the 3D model accurately. Moving quickly through this process, once we have our capture data, we can put this into our photogrammetry software and start creating the 3D model. The alto saxophone did have some complications at this stage, and in order to solve those issues, I processed the data in what I would call a component workflow, where I split the data into multiple smaller parts, process those parts separately as components, and then combine each component into the whole when ready. And after you finish that whole process, you get this lovely final 3D model shown here without any of its color data. Sadly, even with great capture data, every 3D model is going to need some kind of cleanup. And for the alto saxophone, there were areas where I could not prevent the saxophone from reflecting into itself. And this created areas of inconsistent reflections, which creates holes in the final mesh. My method for repairing this is to bring the model into Blender or MeshLab, both third-party 3D editing programs, and manually pair the affected areas of the alto saxophone, which you can see a quick example of here on the left, and the right shows another area where the saxophone was self-reflecting and generated some holes in the mesh. Another one of my favorite new workflows that comes from 3D capture and processing is creating what is called a specular or a glossy map, which tells the 3D rendering or viewing app if an object surface is shiny and reflective versus rough and flat. Blender has a wonderful tool for this that allows you to paint which areas are going to be metallic versus matte or flat. And you can see that in action here in this video, where on the right, I'm painting the saxophone and it's becoming metallic. And on the left, the software is automatically generating the specular map for me. And finally, for the saxophone, we can put all of our processing steps together and deliver the final 3D model for online viewing, interactives, or other related materials. And that was an incredibly fast overview of a very complex project and object. And I'd like to segue into how those challenges and milestones open the door to the way in which I work today and relate some of this to the theme of the conference. Starting off, the Alto Saxophone was the first time I had used many of the 3D editing software that I'm using regularly now. As a photographer, 3D tools like Blender, MeshLab, and others were completely new and have allowed me to reimagine my imaging workflows combining 3D processing tools to achieve 2D imaging results. A great example of this is the ability to create what is called an orthomosaic rendering, which put very simply, it is like a still image created with a normal camera from a singular point of view, except without any lens distortion or perspective. This works incredibly well for paintings and objects that are nearly flat and is a common output for drone and aerial photogrammetry of landscape. One such object was the banner for Public Enemy, as shown here with the orthomosaic rendering on the left and a 3D model on the right. Since the ortho view is somewhat similar to a standard 2D image capture from a still camera, you might wonder why not just make a normal still image. And one good reason is that your view of the subject is obstructed, or the housing or working environment in some way prevents you from being able to use a camera normally, which was true for the Public Enemy banner, as well as this wonderful work of art you see here by local DC artist Akili Ron Anderson. This black piping and lighting obstructed the view of the sculpture. So there is no good way to capture a clear single image of this object using a normal 2D imaging workflow. However, I can use photogrammetry to capture this object from points of view that are not obstructed and then output a 2D image from that data using 3D tools, which is what you see here in the orthomosaic rendering of this object. This flexibility with 3D capture has allowed me to reimagine how I would create 2D imaging for publication or research when normal imaging workflows are out of the question. It has completely opened the door for reshaping our standards and our workflows. Which I will also share that incorporating 3D capture processes and data into our routines required writing brand new standards for file naming, metadata, and project organization to handle the various new 3D file types, derivative 2D files, and accessory data that is generated with 3D content, and there is a lot of it. All of these are questions that also had to be answered for the Alto Saxophone and its subsequent files, as well as for the orthomosaic renderings. The specular map I briefly mentioned, for example, is not a standard 2D image file and is one type of derivative that travels along with the 3D model. In order to preserve this data, new standards had to be created and our approach to handling this data reimagined. Beyond reshaping how I might approach specific imaging requests, I've also had the opportunity as a technician to use new 3D imaging hardware to capture the Point of Pines cabin while it was on display in our museum. The image here on the left is the cabin where it was originally located in Edisto Island, and then I have the 3D model of its current state as found in our gallery space today. This new technology allowed me to 3D image the outside and inside of the cabin at high resolution, which was used to provide an interactive element to our new online project that we call Searchable Museum, where NAMOC is taking a digital-first approach and using these new tools to extend our reach to the public. Finally, I also have to mention how the Smithsonian's Open Access Initiative has also created wonderful moments of reach and engagement to the public for our 3D data that otherwise would most likely not have happened. I really encourage checking out this augmented reality demo created by Twitter user Luke Hurd, where he takes the Alto Saxophone 3D model, which is free to download and use via Creative Commons License 0, by the way, and uses the saxophone model to create a new and exciting AR experience at the Charlie Parker Monument in Kansas City. And I will add the link to that in the chat. Going forward, it is exciting to think about what is possible given the impact that 3D processes and tools are having on our workflows and public engagement. That being said, I will only mention here that to address those challenges and opportunities, I've started a small working group within my museum to find answers, build documentation, and create new collaborations within the museum itself. And the Smithsonian has also started a larger working group to connect all of its staff that are engaging with 3D content through our Digitization Program office. And that's all I have the time, and that's all the time I have for today's presentation. I could speak for hours on this and go in a lot more depth, but please let me know if you have any more questions, and thank you so much for joining. Hello, everyone, and sorry about the snafu at the beginning. And any confusion that may have caused, it looked like some of the pre-recording wasn't edited down, but please let me know if you guys have questions, and thank you again for joining. to well, don't be shy. Um, just checking the chat to see if there's anything there. Yes, so here's one question. Did you use any filters like polarization to minimize reflections? I actually did not for the alto saxophone. The material types and the type of metal that makes up the object probably wouldn't have responded to polarization the same way other objects would. And because my light was being diffused by the scrim at the top and the softbox, I would have had to had a very huge polarization filter to cover that entire surface area, which I did not have. So technically, I didn't think it was needed, and just for resource-wise, I didn't have the resources. But I do polarization for other objects here and there if needed. Can you speak about the trade-offs or value of traditional photography versus 3D digitization? Yeah, and I think I sort of touched base on that just briefly with, adapting 3D to do the orthomosaic instead of 2D. And, if you're working with 2D imaging, I think the main benefit of this versus 3D is that it is going to be slightly more straightforward. It's going to be less work, less processing time. It's going to require less resources. And for example, like if I wanted to do a similar to an orthomosaic, which is that overall 2D image created out of multiple images, you can do the same thing with 2D imaging by stitching. So it's another type of computational process, just a different backbone of algorithms, but you're taking multiple images and the software is going to piece them together into one larger image. I employ stitching sometimes, but in regards to using 3D, and the trade-off here is that the trade-off with photogrammetry and using 3D is like you're going to get a more robust data set, and it's going to be more flexible as well. So with stitching, I think one of the issues is like you have to get really precise alignment and overlap of your images, or you're going to end up with a very difficult set of images to process. But with photogrammetry, you can actually be slightly more loose and varied in the imaging pattern that you use. And I think that is, despite the slightly more image you have to produce, a big trade-off to where like you can have more flexibility there in more tight and more difficult situations with more difficult subject matter. And other trade-offs is, with 3D, it's gonna take more time to process the data generally because you're using a more computer-intensive computational process. So like you're gonna need more robust hardware. Generally, you're gonna need slightly more equipment during the capture process, most likely. So right now, 2D imaging would probably be the preferred method if you have a very short timeline. But in my scenarios, 2D imaging wasn't going to work because I couldn't put the camera in a single place to capture that single view. And stitching was going to be too complicated because you have to be so precise. So 3D gave me that ability to be more flexible there. Yes, so you're welcome. And how did you handle the pearlescent keys on the sax? They were actually my greatest concern, not only because as the view shifted, the surface look and feel of those are going to change drastically, but also the top layer of them is actually semi-transparent, and so there's nothing I can do about that top semi-transparent layer. But my method for them was, again, just sort of doing the initial capture of them with detail, and then doing an additional layers of capture to handle them in different angles and different views. And if you saw my previous talk with DPO on Tuesday, I went into greater detail about this, but your goal there is that as you move the camera around, you're going to be getting shifting luminescence and translucence from that object. And your goal is that as you move that camera around, you want to get a lot of images to where your specular highlights that are shifting are being replaced by like normal looking like a normal looking surface to where it's not a specular highlight. And it's just like the pure color of that object. And if you do that enough, even though your set of images is going to have a lot of shifting reflections or surface highlights, you're also going to have more image data that is made up of just the color data. And that additional image data, those additional passes and those additional look angles are going to allow the photogrammetry software to sort of like override the specular highlights with the normal color data. And this is also, you can also sort of filter this out in the photogrammetry software because those specular highlights are going to have a lot of error. And if you do some additional filtering in those areas, you can remove that as well, and it'll help bring the normal color data out in the model. So there's a couple techniques you can employ, but they generally speaking, you just need to capture more images, more angles, and just try to override the specular highlights with normal color data. Did you already know how to use Blender before the project? Yes and no. I've been like a 3D hobbyist for 10 or so years, and I've always been dipping my toe in here and there. So I have like used Blender and other 3D programs before actually practicing photogrammetry. However, those times I've dipped into it are so far apart that when I came to this project, I was basically a new user. So I had a lot of learning to do, and it was a huge challenge to overcome that. And spent a lot of time on YouTube just figuring out how the software worked by itself. But you know, I encourage people to dive into Blender. The newest versions have a really wonderful user interface. It's much easier to understand nowadays than it was in the past. And you know, once you get going, it goes pretty smoothly. How long did it take to photograph and process the stacks? So the capture process was a day or so of planning, and this was just done in between other imaging projects, part of my normal daily routine. And that planning included like working with the conservation and collections management to identify like proper handling and access. The planning also included a visit by myself so I could physically view the object in person, get a good sense of like how reflective it was, identify the difficult parts like the pearl keys and the chrome and the brass. And then that moved into planning the actual imaging, like how would I tackle this? So that was the start. And that took a day or two of you know, dedicated work. And then the actual capture process, because I had planned all that out, was only 2 days. So the first day of imaging was turntable and experimenting with the macro and the flyover pattern. The second day was filling in holes and doing additional captures for the areas that I felt had a lot of reflections and were going to cause issues. And I did process the data very rapidly overnight, just so I could see what things looked like and where things might be causing issues. And you do that at like a low resolution just to get a sense of the data. Then the post-processing took a little bit of time because I mentioned I had to work with a component workflow. The software had a hard time differentiating the left side of the stacks with the right side and connecting the two, even though I had plenty of overlap. So I had to process those two separately, and then I had to combine them in a component workflow. And I used reality capture, as I'm sure you guys are wondering. But I've also tested this in Metashape, and they give very similar results for the stacks. And that overall process, post-processing, was maybe like a week or two to figure out sort of how to jump through some of the challenges there. and then I must include like the metadata and the file organization was maybe another week to clean that up and sort through that because we were also building those standards during this at the same time. What are the different softwares and apps you use to create a finished 3D model? Are there any other pieces of software that you want to incorporate into your workflows? Typically speaking, I'll start from the very beginning. So I'm typically using a Canon to capture. So I'm using Capture One Pro as a tether software and to manage those files up until it's time to process in the photogrammetry. However, I don't actually use Capture One Pro to process the raw file to TIFF. I use a program called Raw Therapy. That's an open source camera raw editor. And I use Raw Therapy because I think it is more robust and will give you more linear and sort of a truer image to the capture signal that came from the sensor if you handle the program right. Whereas in Capture One Pro and Adobe, I think you're getting a little more actions under the hood that's going to influence the final TIFF. Whereas, so I go from raw therapy to TIFF, and once I have the TIFF, I go into either Agisoft Metashape or reality capture, depending on what is available. We're typically using Metashape at the time, and we have reality capture coming through the pipeline soon. So we'll probably make a switch sometime in the near future to reality capture. And then for 3D processing, once we get it out of the photogrammetry software, my favorite is to use Blender, but you can also use 3ds Max or Maya. We have access to that software as well. I'm just more familiar with Blender, so that's why I'm using that currently. I am looking into switching over to commercial solutions to see if they're any better, and I'm doing those tests for myself now. I also will use XNormal, which is an open source program. DPO has graciously supplied me with Rhizome UV to help with UV mapping and texture mapping. Other than that, I will also use MeshLab to clean up some of the hidden things that can happen inside of a 3D model that you can't see visually, like duplicated faces and vertices and stuff like that. So programs I'd like to use in the future, honestly, I don't know if they exist yet. I really need a neural network or some type of machine learning model that can do some of this work for me. And I would love for someone to make that because that's maybe too much work for me to do. But yeah, those are the typical software I use, and I tend to stick with what I'm familiar with and comfortable using, although I'm exploring some of the programs that I'm not as familiar with. Okay, so you said you had many files to deal with when taking pictures of saxophone. How many pictures are we talking about, and did you store all of the raw files? What is informing your thinking about digital preservation standards for the model files? This is a great question. So the mock had to answer these questions, and we're answering it specific to what we think fits into our current preservation strategies. And I worked very closely with my dance manager, Judith Andrews, on all of this. And I do have the 5-minute warning, so maybe I'll speak quickly on this. For the saxophone, I produced roughly 2,200 images. I kept maybe 1,500 or 1,700 of those in the final 3D model. So I filtered out a lot of them that it was introducing too much air. I do keep for preservation only the images that produce the data that we're going to store for the 3D model. So those images that are out of focus or just are not going to help in some way, like I'm not planning on keeping those. Our preservation process looks like this, to where we're going to convert those raw files to DNG. We're going to embed IPTC metadata that's relevant to the camera setup and the imaging process, but as well as identify which images might go to which part of the 3D model, like identifying images that are just there for the scale and scale bar sets or color calibration versus like this is the bell of the saxophone versus the mouthpiece and stuff like that. We're going to package that data along with the 3D model into a Bagot from the Library of Congress, and we're going to create an organized structure for that data along with the metadata, and we're going to send that into both our dams. the Smithsonian dams, but as well as a new system that DPO is going to be putting out called PackRoute, which I don't know if you guys have heard much about during this conference, but we're very much looking forward to that. And, I think the challenge with the preservation side of this is that because 3D data itself, like the actual 3D model and the subsequent sort of derivatives from that, they don't hold metadata themselves. A lot of our metadata is being placed in Sidecar and really stored into our dam systems themselves. So once that 3D model leaves our ecosystem, a lot of that metadata is not going to travel with it, which is kind of unfortunate. But that really influences how we're handling this as well, is like what can we actually accomplish with the preservation versus the reality of 3D and how proprietary this whole ecosystem really is still. And we're sort of basing it on that. But we have the 2-minute warning here. Maybe if I have one more second for a question. If not, then thank you guys for coming and thank you for your questions. If you'd like to have me dig in like much more deep into any of this, I'm more than happy to. Feel free to email me at Campbell, JA, at si.edu. And I really appreciate the time and that you guys have spent with me here. Thank you.